Unfortunately, I made the wrong press and recording was over, but we're taking again from where we were before. So let's see how much current they deliver. Oh, 5 and almost 5.5 amps, 5.43. This is very high and very good, much better than I was expecting. I was expecting around 4 amps. 5 amps. Okay, that's very good. Okay, so we can say probably around 5.4 amps. I think it's a reasonable expectation. Okay, so 5.4 amps, it's visible enough. Okay, 5.4 amps, and this one we're going to measure again, but I'm expecting roughly the same. Yeah, 5.4 amps, because I'm not going for the highest value, I'm going for a reliable one. So 5.4 amps. Well, this is very good. This is actually very good. A higher value than I was expecting. Okay, we will test all the 4 batteries, the entire set, because I want to see if this is quite consistent, and I assume that you want to know as well. Okay, so let's see. Okay, almost 5.4. Oh, even more. Interesting. I'm pretty sure that the position I'm using for the tip and also the moment when the reading is being made changes initial assessments, but we are roughly at the same value, probably because I have seen a peak of 5.5 amps. Okay, 5.5 amps. Yeah, I think 5.4 also in this case is a reliable value. Okay. But keep in mind that we had peaks at 5.5. So 5.4 amps. And of course 5.4 amps. Okay, so this is the first assessment that we made. And also let's check these ones. We are going to use the recommended way to unpack the set. It went quite well. Not entirely. But we are not going to make any sort of blame about that, because actually when I think about the fact that the pack is made out of cardboard or mostly paper, I think that is a very good choice, a very good environmental choice. So I'm praising it. The fact that it didn't open as expected, to me, it doesn't matter at all. What matters is if we are making good products and we are selling them in a conscious manner, and in this case in a conscious manner, and I think that in this case it's entirely so. So let's see what happens over here, how much current, sorry. Okay. Ooh, even more, 5.7 amps peak. Yes, and it's reliable. Okay, that's a very good result. 5.5. Oh, 6 amps. Yes, that's a very, very good result. Yes, it's consistent, 6 amps. Let's see if I'm going to be able to achieve the same result. Not quite, so this one is almost, this is clearly 6 amps. 5.7, I think. So roughly this is the case. Wow, 6.1 amps. Yeah, that's something. A reliable 6. Okay, so 2 of them can deliver 6 amps, and yes, this one can also deliver 6 amps. Okay, so if I just change slightly the point of contact between the tip and the bottom of the battery, we have reached 6 amps. You may be thinking right now about how I'm going to mark down these batteries. I think I will write them as 5.9 because I don't know if I can write them as 6. I may not be able to 5.9, yes. I think I may not be able to always make the best contact. So this would mean that I would have to take precautions about the value. Yes, also 5.9. Even if it gets over 6 and the peak is there, I think that we will write down the reliable value. And this is 5.9 amps. Okay, 5.9, and I'm going to write 5.9 on all of them because actually the differences between each and every battery was very small. 5.9 and 5.9. Okay, so what we can do further? I think that another important aspect is to see how they stack one battery format to another. 5.4, 5.9. This battery is considered to be able to carry around 800 milliamps hour. This is the battery capacity, and this one around 2300. The difference in capacity is very large, is more than twice. The battery weight, as far as I could tell from typical alkaline batteries, is twice in the case of AA compared with the AAA. The current rating on these two battery types actually show us that there is a very good potential, meaning that good carrying capacity in the smaller types and very good one in the larger type. So I'm expecting the battery capacity to be well represented. I'm not sure if it will reach 2300 milliamp hour for the largest type, but 800 milliamps for the smaller type seems entirely reliable. So probably I'm expecting over 1600 for this battery type. But the fact that those values are in line and the smaller battery has a smaller maximum current carrying capacity or discharge current ability, and this one has an even larger one, point to the fact that their capacity is clearly well represented. I mean that a higher battery has a higher capacity than the lower one, and this is well reflected in the maximum current rating. You should look upon another video I made that was for a set of alkaline batteries also made by Energizer, where I was highly surprised by the fact that the smaller battery, the AAA battery, had a higher maximum current delivered in short circuit conditions than the AA battery, which for me actually was a very good question or a high doubt if the larger battery type is actually made as well as the smaller battery type, because the logical situation would have been for the larger battery type to have higher current carrying capacity and this one to be in line with the battery capacity in general. So if this is not the case, I am expecting that there was some manufacturing reason or design reason why the larger battery type did not have the same current capacity that would have been made if the same technology was used and let's say improved by the amount of space that could make a higher capacity battery. So in this case, I'm thinking that these proportional values are going to reflect well into the battery's behavior in circuit. So I think that overall they are very good products. One more aspect I could be looking at, but is not going to be essential, would be the initial battery voltage. We have to think about the fact that in general this metric is not highly important, because nickel metal hydride cells are having a voltage that is quite stable as they discharge. They are going to have a major drop in voltage only when they have discharge of around 1 volt, and when they are charged they go to 1.3, 1.4 volts, or probably a bit above 1.5 if they are freshly charged. But let's see what is the situation just for our curiosity. 1.2 volts, yes, quite close to 1.3, the voltage I was expecting. 1.2, 1.3 if of course you're going to round up. 1.2, yes, very reliable. It's almost the same voltage. 1.27 volts, and in this case, let's see, 1.3 volts. Interesting. So this one is a bit above, almost 1.3 volts, but still not as high as the first one. 1.3 volts. I think that we can reliably say that these battery types, these AAA battery types, have a slightly higher initial voltage than the AA batteries. Will this matter in practice? No, I think that the difference is less than 1%. So this is around 1%, which is not going to matter much in practice. But this is actually a very good indication of the difference in manufacturing technology and what could be done. Possibly this battery type may have increased losses due to its capacity, or it may not be charged to the same level as these ones. Probably only the first charging cycle may prove if this is the case or not. But before that, I would like to experience how these batteries will handle the initial charge and how long they will be able to last in a specific circuit. What kind of specific circuit? Well, they're not going to be demanding ones. They're going to be in remote applications, so we can probably only say if their behavior was as expected or not after a couple of months. But however, I'm expecting them to fare quite well. So I think this wraps up quite well the video, and I hope that you had a good evaluation or a good first perspective on what these batteries could be able to do. I think that they surpassed my expectations, especially pertaining to the initial current, and I think that this one is a very good achievement. And particularly so, the performance was very good for the smaller battery type, the AAA one. So I'm expecting a very good behavior in the application I was thinking of. So overall, I think that I made a very good purchase, and I think that these batteries will last for a long time. I clearly recommend you buying at least a set of batteries and seeing how they are going to handle your applications. I'm not expecting you to be disappointed, but in general, you should try and see how different battery manufacturers release products on the market, and then see if you should buy more or not of a particular type. But in general, I am totally against buying very cheap or economy rechargeable batteries, because what you are looking at when you are facing the challenge of buying a battery is having enough endurance. And this endurance is not going to be in the amount of hours these batteries will serve you in that particular application, but also in the number of years of reliable operation. And I think that this matters much more than the initial purchasing price. And I think that just about any rechargeable battery that doesn't cost as a set more than the current price of around $15, I think that is going to be more than adequate. Even more expensive batteries, if they offer a higher battery capacity or better performance, they could be an useful purchase. However, I think that those batteries, and in general batteries that are roughly at the same price, handle very well. Again, you may be wondering if this is a promotional video. Far from that. I bought the batteries myself. I have been using rechargeable batteries for many years, and I think that choosing a product over another is a matter of choice, but ultimately you should have also reliable metrics, and in this case measuring the initial current, I think that is one of the most initial metrics you could have about your battery. So it's an essential tool, but also how it behaves in a particular application. If you have batteries that should work at lower temperature or at a higher one, this also will mean that they may behave slightly differently. However, what matters is that you should try and look upon these batteries, and in general, if possible, make a switch from alkaline batteries to rechargeable ones, simply because they are a much more economical one down the line. A couple of years later, you're going to see those advantages. If you buy batteries regularly, it's even more of an important choice right now if you're going for a rechargeable one. And regarding chargers, try to look upon good models, not ones that are overly fancy, but ones that can charge 1 or 2 batteries, have a capacity for at least 4, but perhaps even more batteries. This will be helpful in times, and that can have an individual control of charging per battery set, or ideally each and every cell individually, because in this case you're going to see exactly how a set of batteries behave and how well they handle their useful lifetime. Of course, those battery chargers may be much more expensive than your typical $5 or $10 battery charger, $10 or euros. But I think that it matters to buy a product that is very good, because you want to have the best performance when you're going to charge batteries, and you don't want to let them have useless charging. Although trickle charging, or letting a battery in a charger more than it should be in terms of hours, is not going to have the same let's say disadvantage of stressing the battery as in the case of lithium ones. It's still good if you're going to reduce this exposure and just make the charging and discharging cycle be very consistent. So I hope you enjoyed the video. I think that it was a great choice for making such a purchase. I highly recommend you try at least those batteries, those Energizer AccuRecharge Extreme ones. I hope you will have a good experience using them. And if you like this kind of videos, please subscribe, and also if you have anything to share, please comment. So thank you very much and have a great day. Hello. Today's video will be about a short first evaluation or first insight into a set of rechargeable batteries I have purchased. These batteries should be having quite a good behavior in the future. I meant they should have enough capacity and enough lasting performance. I'm expecting them to fare quite well. However, keep in mind that this is with batteries that are actually taken out of the pack, so the performance may not be the maximum it will ever be. However, it's a good assessment of the initial expectations that we have going forward. So what we are having over here is a set of rechargeable batteries of the AA and AAA variety. Both of them should be of quite a good performance. I mean that they are not necessarily the economy or mid-range rechargeable batteries from Energizer. They are the top products, the top of the line products, so I think they should have quite a good behavior in time. Also, I would like to test the performance of these initial batteries in terms of the initial amount of current they may deliver, because this will be a good indication of what to expect from this battery technology. I'm expecting the higher batteries to have at least the same current carrying capacity in short circuit as the smaller ones, but we will see if this will be the case. I'm also expecting something in the range of 3 or 4 amps being delivered by the larger batteries, and we will see if this will be the case. So let's see what happens. Also, I will be making a marking on these batteries because I want to know how much current they were initially able to offer. And also I have to mention the price. Well, these batteries cost around 11 US dollars or around 9 euros. This is not a bad price in the least. I think it's one of the best prices you can find for this type of batteries right now. When you are making an evaluation, you should consider that having rechargeable batteries means at least 500 times recharges are possible, so the battery actually has a useful life that can reach years. So when you're actually thinking about buying rechargeable batteries, you're actually making a very good investment if you are going to use them regularly. If you're just going to use them rarely, then yes, probably it's not going to be a major difference. So probably remote control applications are going to be the least interesting in this circumstance. If we are looking at the labels, I don't think they say too much. Okay, I was looking carefully at one aspect. They seem to be made in Japan, which is actually a very good decision. It means that these batteries should have a very high quality manufacturing process. And the smaller one, the AAA batteries, are also made in Japan. Yes, it's a fantastic choice, especially considering the performance, price, and expectations you have with such batteries. So a first world economy manufacturer, and in my opinion, some of the best batteries, if not the best batteries in the world. So yes, a very fitting choice. Alright, so let's test the AAA batteries first. We are going for the current rating. And let's see what happens. Of course, I'm going to place it so that you can also see it better on the camera.